All right, Ella, this is 4-3. You should be on page M580. You will also probably want to have Desmos open as well. This should be pretty short. It's only this page, but there are quite a few things that we can get from this page. So here it gives us a quadratic function. Again, this is cut off a little bit. There we go. It's in factored form, which previously we had it in general form. And from general form, it's really easy to figure out the y-intercept. When you have something like this in factored form, this actually looks like vertex form, to be completely honest. You can't find the y-intercept, so we have to type that in to find it. So I believe if I'm actually, now that I'm looking at this, I think this is in vertex form, which we didn't talk about vertex form, but we can still answer questions to get us here. So we have h of t equals -5 t minus 3. It's just easier for me to see because it's kind of blurry. Yeah, it looks like this is vertex form, which again, we're not going to discuss necessarily. Vertex form just kind of helps us with that vertex. So our vertex is going to be 60 is really what that does for us. So here it says to sketch the graph of the function, label the vertex and the y-intercept. So we have this little graph over here, but we're going to go ahead and type this into Desmos. So we have -5 t minus 3 squared. Oops. Plus 60. All right, where is it? Oh, sorry, it must want h of t equals. There we go. Okay. So here it is. So they want us to sketch the graph, and it says we need to label the vertex, the y-intercept. So here we go. Our y-intercept is 0, 15, and our vertex is 360. So if we go back here, we're just going to quickly, nothing too big. We could go by tens probably. So 10, 20, 30, 40, 50, 60, and then 1, 2, 3. So 360 would be here. And then we need the 15. So it just kind of goes like this. Main thing is here is let's go ahead and just make sure that we know that our vertex is 360. And then that our y-intercept was 0, 15. So again, as you can tell from this vertex form that they gave us, you can't figure out the y-intercept. We'd have to actually type it in. And then notice here you can find the vertex of 360 from that vertex form. Okay, so what they want us to do here is they want us to identify the table that represents the function and explain why we eliminated them. So since we know already, again, your first step here would just be to type it into Desmos. So we're just comparing this function to these tables. So our y-intercept is 0, 15. So really what I would do is just look for those. Here it's 0, 60. Here it's 0, 45. Here doesn't even have one. It doesn't look like. Oh, yeah, it does. 0, -45. Sorry, I couldn't see that. It's kind of choppy. And then here is 0, 15. So we're picking C as our answer because the y-intercepts are the same. And that's really it for that part. Now, this bottom part is pretty important. I really like this question. It really kind of shows us if we know what we're talking about here. So it says, describe how the function h of x. Oh, that's an x, not a t. Oh, no, it is. Okay. They just changed it from a t to an x. Describe how the function h of x was transformed from a basic function of f of x equals x squared. So what they want us to do, I'm going to go back to Desmos. Here's our equation. They want us to know how it got from f of x equals x squared So they want to know, how did we get from this blue to this red? Like, what changes did we make? So if you would have had to do the Desmos activity from the remote day or from Monday, depending on which you did, but that tells us a lot. So like, first of all, as you can tell, this blue line's a little bit thicker, like wider than the red. You can tell it flipped, and then you can tell that it's shifted over. And so we can tell a lot of that here. Sorry, I'm on the wrong thing. Okay. So we want to know how we went from just a generic parabola to this one. And don't worry about the H's and the F's and all that kind of stuff. It's all f of x. It just depends on what they put in there. Oh, this is a t. Okay. So obviously lots has changed. So we have this t that would end up being squared, which is like the x squared. That's really the only thing that stays the same. So here's how it transformed. So that this number right here is our leading coefficient. So the -5, first of all, the negative shows us that it flips. So that's why it flipped to go upside down. The 5 makes it, I'm going to say skinnier. It's not really the right word, but it kind of makes it go from this being a little bit wider to then obviously it flipping, but then a whole number makes it a little bit skinnier. So obviously 1 is a whole number because there's an invisible 1 in front of the x squared, but the bigger it gets, it's going to make it a little bit skinnier. If you look at this -3 right here, and this is what you should have gotten from the Desmos activity, if you have that -3 is inside the parentheses, that's telling us, I don't know why that just did that, that it's shifting right. So you should have seen from, sorry, this Wi-Fi is not working, which is why this is not writing appropriately. So that's that word is shifting right. So if you have a number inside those parentheses at any time, it's going to go left or right. If it's a negative, it goes right. If it's a positive, it means it's going left. So you're kind of taking the opposite there. And then the 60 on the end, the 60 outside the parentheses, which again, you should have learned from that Desmos activity, means that you're going up 60. I don't know why this isn't working very well. So that's what you need to get from that, is to be able to notice all those things. And that's from that Desmos activity where we kind of made those transformations ourselves. All right, that's 4-3. I'll do 4-4 next.